All right, Chapter 9, Google Cloud Key Management. Google Cloud Key Management Service, Cloud KMS, is designed to provide a scalable, reliable, and performant solution with a wide spectrum of encryption and key management options under your control. This chapter revolves and explores how Cloud KMS helps organizations maintain security and compliance while managing cryptographic keys for cloud-based applications and data. Here's an overview of Cloud KMS. Okay, let's go here. All right, Cloud KMS enables administrators to manage cryptographic keys for protecting data in Google Cloud through multiple interfaces. One, Google Cloud Console, a web-based graphical interface. Google Cloud CLI, the command line interface. And REST or gRPC APIs for application integration. Okay. When creating a key in Cloud KMS, you need to select the protection level that defines which backend should be used for the key. Cloud KMS offers two main protection levels, excluding Cloud External Key Manager. One, software protection. Keys protected by software security modules. This complies with FIPS 140-2 Level 1 requirements, and there's a lower cost option suitable for many general use cases. Two, HSM protection. Keys protected by hardware security modules, HSMs. These comply with FIPS 140-2 Level 3 requirements, and they offer higher security for sensitive applications and regulated industries. All cryptographic operations in Cloud KMS are performed by FIPS 140-2 validated modules, ensuring compliance with government and industry standards. I'll add these into the chat, so if you're looking at this in playback, you can go here, view these resources. Encryption options in Google Cloud. Google Cloud offers a spectrum of encryption options to meet different security, compliance, and operational requirements. One, default encryption. This is automatic encryption of all data at rest. It's managed entirely by Google with no customer access to keys. There's no key rotation control for customers, and it's included at no additional cost. Two, Cloud KMS. It's customer managed keys generated and stored by Google. There's full control over key creation, rotation, and deletion, customer control of the key type, algorithm, and protection level, and keys remain within Google's infrastructure. Three, Cloud HSM. Keys are generated by Google and stored in Google-owned and operated HSMs. There's higher security validation, like FIPS 140-2 Level 3, and hardware protection of keys with tamper resistance, and it's more suitable for regulated industries. And then four, key import. You can import existing keys used and managed outside of Google. You can use your own key material in Google's HSM. It maintains consistency with existing key management systems and has support for both software and HSM and protection levels. So we'll show you how to import keys from the console. One, go to the key management page. All right, and then let's see, here for keys here. Where is it? Why am I not seeing it? Key inventory. These are my keys. Huh? Why am let's say KMS infrastructure? Create key management from external key manager. So this would be one. Okay, you create the name, the location, all right, the directory, all right, to use for the service to use with the connection, and then the key EKM, the key manager host name. Get your certificate, your management mode, click create. All right. You can also use the Cloud CLI to do this. It's authorizing. You enter the following. Okay. G-Cloud KMS import-jobs, create my-import-job, and you'd have the location set for whatever location, the key ring, wherever your keyring's name is, the import method for the RSA, security encryption level, and then the protection level. All right. And you can describe the import job to get the public key with the following. That'll be gcloud KMS import-jobs, describe my-import-job, then the location, the keyring, and the format for the PEM.RSA. And then you import the wrapped key material. Okay. All right. Now it'll be gcloud KMS keys versions import, the location for the region, and then the key ring, your key, the import job name, the algorithm, and then the wrapped key file. All right. And you replace this as needed for what you have. Okay. So there's customer supplied encryption keys. These are keys owned and managed by the customer. They're provided on each API call for ephemeral use. They're used for cloud storage and compute engine, and there's no persistent storage of these keys by Google. There's also the external key manager we just showed. These are keys stored in an external management system of your choice. These keys can remain outside of Google Cloud. The integration with supported third-level key party management partners, and Google never has possession of the key material. Let's go a little bit into Cloud KMS design policies. So Cloud KMS is built on 5 core design policies that ensure a secure, reliable, and customer-controlled service. 1, customer control. Customers can handle software and hardware encryption keys through Cloud KMS or import their own keys. This gives organizations flexibility to meet their specific security and compliance requirements. 2, control and monitoring of access. Cloud KMS provides fine-grained permissions management for individual keys and comprehensive logging to monitor how keys are used. This allows organizations to implement the principle of least privilege, and maintain a detailed audit trail. 3, regionality. Cloud KMS has regionalization built into its architecture. Software keys are only produced, stored, and processed in the Google Cloud locations you specifically choose, allowing for data residency compliance. Durability. The service maintains stringent durability requirements with regular checking and backing up of key material and metadata. This protects against data corruption and ensures data can be correctly decrypted when needed. Security, but number 5. Cloud KMS integrates fully with IAM, it's Identity and Access Management, and Cloud Audit Logs, providing robust protection against unauthorized access to keys. Cloud Audit Logs help you understand who used a key and when. So let's go over key management terminology. And let's understand Cloud KMS requires familiarity with several key concepts. The key. Now, what is the key? See if I can find this. Nice resource for you. There's import. There's key. Okay. Okay. So a key is a named object representing a cryptographic key used for specific purposes. The key material, actual bits used for cryptographic operations, can change over time as new versions are created. Cloud KMS supports symmetric and asymmetric keys. Symmetric keys are used to protect data with AES 256 encryption in Google Cloud Module. Asymmetric keys are used for asymmetric encryption or for creating digital signatures. So let's show you how to create a key. Okay. You're in the console here. So you'll be here, go to security, key management, or no. Yeah, key management, there's key rings. Oh, and that's a ring. And we create a key. Okay. Create the name, protection level for software or HSM. Choose the key material. Is it generated or imported? If it's imported, this is already existing key material. Select the purpose. Is it going to be for encrypt, decrypt, for symmetric? Or is it going to be for asymmetric, to sign or verify? Or is it going to be asymmetric for encrypt, decrypt, right? And then you can go for the rotation, how often you're going to switch this key out. 90 days is solid, 30 days is better, right? And then you can have additional settings here for destruction date, and you can add some labels for better tracking, and you click create. All right, we're going to cancel this out. You can also do this through the CLI with the following command. Gcloud KMS keys create my-key location, your central, my key ring for the key ring, encryption for the purpose type, and then protection level. This was source software. All right. So we showed you how to create the key. We'll go back and show you the key ring. All right. A key ring is a grouping of keys for organizational purpose. Key rings belong to a Google Cloud project. They reside in a specific location. They allow keys to inherit IAM policies from the key ring. They help organize related keys with similar permissions. They cannot be deleted to prevent resource name collisions. And they have no billable costs or quota limitations, right? So to create this in the GUI, on this hamburger menu, security, and then key management, and then you're at the key rings, create the key ring, add the name. You want to do it regional, multi-regional, or set it for global or specific region, and click create. All right. And you can also do this via the CLI. Following command, gcloud KMS keyrings, create my-keyring, and then location, your central one. All right. And then you replace my keyring and US Central One with your desired keyring name and location. Key metadata. Resource names, properties, and derived data such as IAM policies, key type, key size, key state, etc. Key metadata can be managed differently than the actual key material. So key versions. These represent the key material associated with the key at a specific point in time. The key version is the resource that contains the actual key material, numbered sequentially starting with version 1. When a key is rotated, a new key version is created with new key material. Symmetric keys have a primary version used for encryption by default. For decryption operations, Cloud KMS automatically identifies the key version needed. Key versions can only be used when enabled, and all versions in a state other than destroyed incur costs. Purpose. So the key's purpose determines whether it can be used for encryption or for signing. You choose the purpose when creating the key, and all versions have the same purpose. So for symmetric keys, this would be for symmetric encryption or decryption. For asymmetric keys, it could be for asymmetric encryption or decryption or asymmetric signing. The purpose cannot be changed after key creation. State. A key version state is always one of the following: enabled, disabled, scheduled for destruction, or destroyed. So there's a key hierarchy in Google Cloud. Let me see if I can get a good visual for you. Give me a moment to. Oh, this might be it. That's the resource hierarchy. That's not what we're looking for. Management and service is closer. That looks like it. All right. I'm going to add that to the resources. Okay. So Cloud KMS is built on a multi-layered hierarchy to ensure security at every level. One, data encrypted with data encryption keys. That's DEKs. DEKs are managed by Google Cloud services on your behalf. Two, DEKs are encrypted with key encryption keys. That's KEKs. KEKs are stored in Cloud KMS. You control the KEK through all Cloud KMS platforms options: software, hardware, and external backend. Three, KEKs are protected by the KMS master key. The KMS master key is distributed in memory. It's backed up on hardware devices. Four, KMS master key is protected by the root KMS master key. This is Google's internal KMS key. This multi-layered approach ensures that even if one layer is compromised, the data remains protected by the other layers. So here's the basics of encryption. One, Envelope encryption. Envelope encryption is a cryptographic technique that uses multiple layers of encryption to protect sensitive data. The process involves the following: encrypting data. This means generating a data encryption key, a DEK, locally. Use the DEK to encrypt the data. Use key encryption key, KEK, from Cloud KMS to wrap, encrypt the DEK, and then store the encrypted data and the wrapped DEK together. 2, decrypting data. With this, you would retrieve the encrypted data and wrapped DEK, use the KEK stored in Cloud KMS to unwrap or decrypt the DEK, and use a plain text DEK to decrypt the encrypted data. The KEK never leaves Cloud KMS, providing an additional layer of security. This approach is known as envelope encryption and is handled automatically for Google Cloud customers. So, key management options. Let's go over these. So, Google Cloud default encryption. Google Cloud automatically encrypts all data at rest using Google managed and default encryption keys. These AES 256 symmetrical encryption keys require no setup or configuration. Google manages both the keys and a reputation period. This approach is suited for customers without specific compliance or regional requirements for cryptographic key material. It's simple to use, requires no additional configuration, and comes at no additional cost. Customer managed encryption keys, CMEKs. For customers with stringent regulatory and compliance requirements, Google Cloud offers the ability to manage encryption keys with Cloud KMS. With CMEKs, customers can select the key type, like software or hardware, choose the algorithm strength, control key rotation schedules, disable keys used to safeguard data at rest, limiting Google's ability to decode it, protect data using keys specific to their location, rotate keys automatically or manually, and use Cloud HSM, Cloud External Key Manager, EKM, or import existing keys. So CMEK integration. Let me see if I can find something for this. So many cloud services support CMEK integration. To enable CMEKs, do the following. And let me clear some of this off. Huh. Let's try this. Let's get this in here. Okay, so to enable CMEKs, you one, create or import a Cloud KMS key in a location geographically near your service resources. 2, grant the cryptographic key encryptor decryptor IAM role on your CMEK to the service account for the relevant service. If I can find this. All right, and 3, configure the service to use CMEK to protect its data. All right. If you revoke the role or disable destroy the CMEK, the data can no longer be accessed. Rotation of CMEK won't impact data availability since the service keeps track of which CMEK version was used to encrypt data. Some services don't offer direct CMEK integration, but are CMEK compliant if they encrypt temporary data with ephemeral keys that are flushed from memory when no longer needed. Customer supplied encryption keys, CSEKs. With CSEKs, you provide your own AES 256 key encoded in standard base64 format as an additional layer on top of Google managed encryption keys. CSEKs are supported by cloud storage and compute engine. CSEKs with cloud storage. When using CSEKs with cloud storage, 1, cloud storage doesn't permanently store your keys on Google services. 2, you provide a key for each cloud storage operation, and your key is purged after the operation completes. 3, cloud storage stores cryptographic hash of your keys for validation of future requests. And 4, your key cannot be recovered from this hash, and the hash cannot be used to decrypt your data. Best practices for CSEKs with cloud storage include backing up each key to a secure location, taking precautions to ensure keys are not shared with untrusted parties, and immediately rotating keys for all objects encrypted with a compromised key. When applying a CSEK to an object, cloud storage uses the key to encrypt the object's data, the object's CRC32C checksum, and the object's MD5 hash. Cloud storage uses standard server-side keys to encrypt remaining metadata, such as the object name, allowing you to read and update general metadata, and list objects without needing the CSEK. Limitations of CSEKs with cloud storage include cloud storage transfer service and data flow don't support objects encrypted with CSEKs. The Google Cloud Console can't be used to download and upload objects with CSEKs. CSEKs can only be set on individual objects, not as a bucket default. For composition operations, component objects must be encrypted with the same key. CSEKs with GSUtil. So to use CSEKs with GSUtil, you must do the following. Add the encryption key parameter to the GSUtil section of your Bodo configuration file. See if I can get this. I'll get some of this for you. Okay. All right. The encryption key is an RFC 6848 base 64 encoded string of AES 256 encryption key. You can specify one or more decryption keys up to 100, right? And encryption and decryption keys in the Bodo configuration files are used for all GSUtil commands. During decryption, GSUtil calculates the SHA 256 hash of supplied keys and selects the correct key by matching the hash in the object metadata. For encrypted objects requiring key rotation, you can rewrite the object using the JSON API, which is not supported in the XML API. All right. So CSEKs with Compute Engine. Compute Engine encrypts all data at rest on persistent disks using Google's default encryption keys. With CSEKs, you can do the following. You can control and manage encryption yourself. Compute Engine uses your keys to protect the Google-generated keys used for encryption and decryption. Only users who provide the correct keys can use protected resources. Google does not store your keys and can't access protected data without your key. And if you lose your keys, neither you nor Google can recover the data. Restrictions when using CSEKs with Compute Engine include the following. You can only encrypt new persistent disks, not existing ones. You can't use your own keys with local SSDs. They're already protected with ephemeral encryption keys. And Google Compute Engine doesn't store encryption keys with instance templates. So store your keys in Cloud KMS for managed instance groups. So we're going to show you how to manage key permissions. Let's go to the key management page. All right, we'll click on a key ring. We'll click on a key. And then from here, we can do labels, but let's do permissions. All right, and with permissions, you can enter the principal, add a new principal by their email address, john@johngo.com. Add the roles that would be associated with it. All right, and then add I am conditions, and then click save, and then you would be good to go. All right, and you can also do this with the Cloud CLI. I'll enter this here. You'll see this command is gcloud KMS keys add-im-policy-binding my-key, and location US Central, keyring, my keyring, and the member, that would be the principal, user at, this is the email address, and then the role that you would be applying to it. Okay. So symmetric and asymmetric key encryption. Let's go into this a little bit more. So symmetric key encryption uses the same key for both encryption and decryption. In Cloud KMS, this typically involves AES 256 in GCM mode to encrypt blocks of plain text. Symmetric encryption is faster and more efficient for encrypting large amounts of data. Asymmetric encryption. Asymmetric encryption uses a key pair. One, a public key that can be shared, and a private key that must be secret. The sender encrypts the data with the recipient's public key, and only the recipient with the matched private key can decrypt it. Cloud KMS provides functionality for asymmetric encryption. This does it through the following ways: creating asymmetric keys with the purpose of asymmetric decryption, retrieving public keys for asymmetric encryption, decrypting data with private asymmetric keys, and supporting for asymmetric signing with ECC and RSA algorithms. Now we have bring your own key, BYOK. Google Cloud allows you to bring your own cryptographic key material and import it using either software or Cloud HSM protection level. This approach benefits organizations that have existing cryptographic keys created on on-premises and internal and external key management systems, are migrating applications to the cloud, or need to add cryptographic support to existing Google Cloud applications. The import process works the following way. And let's go over here. Let's close out some of this. All right. We'll leave that. So, all right. So Cloud KMS generates a wrapping key, let's say a public-private pair, right? And your key material is encrypted with the public wrapping key for protection during transit. And then the private key, matching the public key, is stored within Google Cloud and used to unwrap the key upon arrival. Okay, so prerequisites for bringing your own key include automatic wrapping with G Cloud, installing the PYCA cryptographic library, and then for manual key wrapping, you would configure with OpenSSL, and then you would verify your key's algorithm and length are supported by Google Cloud KMS. All right, so there's a key lifecycle. Cloud KMS follows the key management lifecycle described by the National Institute of Standards and Technology, NIST. The lifecycle is divided into 4 phases. 1, pre-operational. The key import is importing external keys into KMS. The key creation is when you create new symmetric or asymmetric keys in Cloud KMS. 2, operational. The operational phase is when normal storage, so storing keys in software, HSM, or external protection levels, and then key rotation. This is creating new versions of existing keys. And there's a post-operational phase, which is key disabling, so temporarily preventing use of a key, and then key destruction and recovery. This would be permanently destroying key material. Cloud KMS offers the ability to disable a key after rotation. So this allows you to confirm that no additional data needs to be encrypted before the key is destroyed. And you can re-enable a disabled key if you discover that data needs to be decrypted. And the 4th portion is rotating keys. So using the Cloud Console, here's what we'll do. You go to the key management, which we're at the key, you click rotate. You would rotate this by clicking this button, confirm the rotation, a new key will be created, and it'll set as the primary version. All right. You can also do this in the Cloud CLI, the following: gcloud KMS keys versions create, set the location, the key ring, and the key, and this will create the newest version. KIM permissions. Managing access to Cloud KMS resources follows the key hierarchy: keys and key rings, projects, folders, and the organization. Best practices for managing access include grant key management roles based on job function, typically managed by IT security teams. For large organizations, grant Cloud KMS administrator roles to IT security team members across projects. Grant granular roles for specific key lifecycle aspects, like Cloud KMS importer role. Grant Cloud KMS encryptor-decryptor role to users or service accounts that need to read, write, encrypted data. Grant Cloud KMS public key viewer role to entities that need to view public keys for asymmetric signing. Consider hosting keys in separate Google Cloud projects from the data they protect. Avoid granting the owner role to any member. Use Cloud KMS administrator role instead of owner for broad administrative access. For sensitive data, restrict who can access and use keys for decryption. For projects using the VPC service controls perimeter, use a separate Cloud KMS project within the perimeter. Cloud HSM. Cloud HSM is a hosted hardware security module service that lets you host encryption keys and perform cryptographic encryption in FIPS 140-2 Level 3 certified HSMs. Like this. Okay. All right. So with Cloud HSM, you don't need to worry about patching or scaling for multi-regional applications. It uses Cloud KMS as its front end, allowing you to interact with Cloud HSM through the familiar Cloud KMS APIs. The architectural characteristics of Cloud HSM include hardware-backed keys provided to Cloud KMS, available auto-scaling horizontally to handle unpredictable workloads, Keys cryptographically bound to the cloud KMS region specified at creation. Keys cannot be exported outside of the HSM cluster. Attestation that keys are created and used exclusively within hardware devices. No application change is required for existing cloud KMS customers. And optionally, PKCS number 11 compliant C++ library, so lib KMSP 11. This is for advanced use cases though, right? So security features of cloud HSM include customer keys are wrapped by HSM root keys, HSMs not used as permanent storage for keys. There's multiple types of keys with different rotation policies. There's rigorous provisioning and handling processes in secure facilities. There's vendor-controlled firmware that's digitally signed. There's strict regional boundaries for keys. There's FIPS 140-2 Level 3 certification with tamper evidence. There's protection from malicious interference from other services or tenants. And there's robust key creation and attestation processes. So Cloud External Key Manager. We'll go back to this a little bit. Cloud External Key Manager allows you to use keys that you manage within external partner key management systems. The benefits include key provenance, which is where you control the location and distribution of externally managed keys. The keys aren't cached or stored within Google Cloud. And Cloud EKM communicates directly with your key management partner for each request. There's access control, where you manage access to externally managed keys and can revoke Google Cloud's access at any time. There's centralized key management, where you can manage your keys and access policies from a single location interface, regardless of where your data resides. Supported partners include Fortanix, Futrix, Thales, and Virtue. There's cloud EKM considerations though, right? This can be used with hosted private HSM for a single tenant HSM solution. Google has no control over the availability of externally managed keys. But remember to review guidelines about external key management partners and regions. They vary. And review the Cloud EKM service level agreement. You want to know the details? They're there. Communication over the internet may affect reliability, availability, and latency. And remember, you need a support contract with your external key management partner to perform this. There are Cloud EKM restrictions as well. One, automatic rotations aren't supported. New EKM keys created via API or CLI must not have an initial key version. EKM operations have specific quotas beyond regular Cloud KMS quotas. Symmetric keys have specific restrictions. They're only supported for CMEK integrations. And asymmetric keys have algorithm limitations and specific use cases. So here's some best practices for Cloud KMS. For key organization and access management, one, create a dedicated project for KMS separation from workload projects. Add key rings to dedicated KMS projects and create key rings as needed. Monitor privilege administrative operations. Review CMEK-related findings in Security Command Center. And use encryption keys with appropriate key strength and protection level based on data sensitivity. A couple of notes on IAM role management. Avoid basic project-wide roles like owner, editor, and viewer. Designate an organization administrator at the organization level. And use KMS predefined roles for least privilege and separation of duties. Separate administrative roles from usage roles. Limit role assignments to security administrative teams, those team members, or service accounts. For asymmetric keys, grant private key access separately from public key access, and grant the most limited permissions at the lowest level in the resource hierarchy. A couple of notes on application data encryption. Applications may call Cloud KMS APIs directly or use envelope encryption. And envelope encryption provides better application availability and scaling. A couple notes about key import ceremonies. When importing keys from outside of Cloud KMS, conduct a formal key ceremony. A key ceremony provides assurance to reliant parties that keys are stored and used securely. After the key ceremony, enable the key in Cloud KMS for cryptographic operations. Cloud KMS API and audit logging. So Cloud KMS API uses the endpoint cloudkms.googleapis.com and provides extensive audit logging capabilities. This includes admin activity audit logs. So when you include admin write operations that modify metadata or configuration information, these logs cannot be disabled. There's also data access audit logs. When you include admin read operations for metadata and data read-write operations for user-provided data, these logs must be explicitly enabled. So let me show you where you can find a little more information on this. Um, Here's key rotation, and then it added logs. Okay. Yeah, we'll add these as well, and we'll wrap up this chapter. Just give me a moment or two. Okay, so these are all here. So, in conclusion, Google Cloud Key Management Service offers a comprehensive suite of options for managing encryption keys in the cloud. From default encryption to hardware security modules and external key management, organizations can choose the approach that best meets their security, compliance, and operational requirements. By understanding the key concepts, architecture, and best practices of Cloud KMS, security professionals can implement robust encryption strategies that protect sensitive data while maintaining control over cryptographic keys. Whether you're looking to simplify key management, meet regulatory requirements, or integrate with existing key management systems, Cloud KMS provides the flexibility and security features needed for modern cloud environments. Thank you. I hope you enjoyed this. Next up will be Chapter 10 on Cloud Data Loss Prevention. Have a good day.